All right, looking at number 1 on your practice test, the table shows the amount Andre earned as a waiter. The money in dollars is the total amount he earned. So we've got our times here, and then and that's how many hours, and then the amount of money that he's earned. Determine a linear regression equation for the data. So if we want to determine a linear regression equation, we have to use our calculator. So we're going to grab our calculator. And the buttons that you should know how to push here are stat and then enter. Okay, stat enter gets you into your L1 and L2 so you can input your data. If you want to clear out what's in there, you want to go up to the L2, hit clear and enter, and it'll clear everything that's in that column. Okay, same thing with L1. You want to clear what's in that column, clear, enter, clears it out. And then we just input the data we see here. So in our L1, we're putting 0, 1, 2, 3, 4, 5, 6, and 7. And then we jump over here to our L2, and then we're putting our L2 data. And you should have the same amount of numbers in your L1 as you do in your L2. If there's more over here or more over here, you mess something up. Okay, and it's not a bad idea to double check your data, because if you mess up your equation here, if your data is messed up, it's going to mess up your equation, your correlation coefficient is going to be wrong, and then when you try to actually answer a question using it, it's going to be wrong. So we have our data in. Then we go stat over to calc. So we're going to calculate our linear regression. So that's number 4. You can either hit 4 or you can go down to 4 and hit enter. And it should be pulling from our L1 and L2. Your calculator, please stop in the office. Your calculator might look like mine, and yours might not show it like this. If yours doesn't show it like this, it should just say like lin reg at the top, and you hit enter and it'll give you the equation. If it looks like mine, you're just going to go down here till you get to calculate, and you go ahead and calculate it, and it gives us the equation here. So this is the equation that we have, and then if we read the directions here carefully, it says determine a linear regression equation for the data, round the slope and y-intercept to the nearest whole number. So we want to make sure we round them to the nearest whole number. So we have y equals, and my a is 14.3 something, so that would round to just 14. We don't round it up. So we got 14x plus, and then our b is 2.25, but we want it as a whole number, and the nearest whole number to that would be 2. So that should be what you have for part A. And the correlation coefficient, whenever you see identify the correlation coefficient, it's the R value, okay? So if you see correlation coefficient, you should always be thinking R. So our R equals 0.99697. And then there's another question here. What does this tell you? It's telling us that it's a strong positive linear association. Okay, it's strong because it's close to 1. So I would write all of that stuff. Strong, positive, and linear. Okay, and predict the amount earned after 9 hours. So if we want what it is after 9 hours, remember our x's here. Let me get this out of the way. Our x's here were the number of hours. So if we want 9 hours, we just want 9 for our x. So we're going to take our equation we have right here and we're going to plug 9 in. So we're going to do 14 times 9 plus 2. Or you could put this into your y equals in your calculator, and you could look at the table at 9, but being we're only looking for one value, it's pretty quick to go about it this way. So grab your calculator. 14 times 9 plus 2, 128 is what we get then. And that's the money in dollars, so I'm going to call it $128. and show your work and explain your reasoning. So this is me showing my work here and explaining my reasoning. I would say that this is going to be at x equals 9. All right, so number 2. Here we're given a new table. So the table shows the decrease in the amount of chicken feed in a farmer's barn over a 7-month period. Determine a linear regression equation for the data. So typically when we're doing this, we're going to start wherever we're at here. We're going to call this month 0, because we can't like type March into our calculator and have it know what that means. So March is 0, so then 1 month later would be 1. May is 2 months later. June is 3 months later. July would be 4. August and September. Okay, so that's what's going to go in our L1 then. So month 0 would be March. So let's get that in our calculator. Same idea as what we just did. So if we hit stat, enter, I'm going to clear out what's in my L1 and L2. If you need a slower version of this, you can go back and look at number 1, the recording. Okay, we've got 0 through 6. And then we hop over and we put the other values in our L2. Be careful that you don't mess them up here. If you mess up here, it's going to mess up the whole problem. And once we have the data in linear regression, we go stat, over to calc, down to number 4, linear regression. And then you hit enter, and it should give you an equation and a correlation coefficient here. So determine the linear regression equation for the data. This time it doesn't say to round to any certain value, so I might go to a couple decimal spots here. So we've got y equals negative 77.68 x plus 944.32. Interpret the equation in terms of the problem situation. So when it says to interpret, you want to look at your slope here and interpret that, and then look at your y-intercept and interpret that. So our y-intercept would be, if you think about where our y-axis is here, our y-intercept, where it hits that y-axis, is 944.32. That would be when our x value is all the way over here at 0. So if we think about for this problem what that means, if our x is 0, that would be what it's telling us the number of pounds are going to be in March, and it's telling us, our equation is telling us that the number of pounds would be 944.32, which is pretty close to the actual value. Okay, you're not always going to get exactly what it is because the line is an approximation. So let's start with that. The first month, so in March, we could say here, or in month 0. And I think it was the feed, the chicken feed is the 944.32. So the amount of chicken feed. And then make sure you label, so this is in pounds. All right, and then the other part here was the slope. So because the slope is negative, that means that the amount of pounds is going down by that much, right? A negative slope would be going down. So it's going down by this much every time your x goes up by 1. So for every 1 month since March, the amount of feed decreases by that much. 77.68. And again, that's in pounds. Okay. Then it says to predict the amount of feed in December. So we need to figure out what December is for this problem. If we're at September, you might have to write it out. September, then October, then November, then December. So just be careful you get the right spot. So this is 5, 6, this one would be 7, 8, 9. So if we're looking for December, I'm going to say my x is equal to 9. And then I am going to put this in my y equals this time. So for number 1, I didn't do it this way. For number 2, I'm going to do it this way. I'm going to put this equation in my y equals. So how most of you know to do that is just go to your y equals right up here. And we're just going to type this equation in. So negative 77.68 x plus 944.32. All right, and I want to know when x is equal to 9. So if I want to know when x equals 9, if we go second table set, it's right above the window here. So second and then that button. I'm just going to start at 9 and go by ones. And then if I go second table, I will see this table with all these different values. So at 9, I'm at 245.2. So that would be my answer here, be 245.2. And that's the number of pounds. They predict the amount of feed in February of the following year if the decrease in feed continues at the same rate. So if we want to get to February, we're at October, November, December, then we'd have January, then February. So we're at 9, 10, 11. So here we're talking about x equals 11. The nice thing is I already have it in my calculator, so to find what it is at 11 here, it's 89.84. Is the linear regression equation a good indicator of the amount of feed in the future months? Explain your reasoning. I would say it's probably a good indicator for maybe a little bit, but pretty soon we end up with these negatives. And that doesn't make a whole lot of sense, right? Because that negative slope is going to continue to decrease, but at some point we would hit 0 and we would be out. So is it a good indicator? I would say it's a good indicator until it hits 0 probably. So let's go ahead and say yes, but only until the feed is gone. And why is it a good indicator? If you look at our R value, so if you do this linear regression again, or if we had written it down, whoops, I did the wrong thing here. Okay, if I go stat, over to calc, down to linear regression, remember that R value? That R value here tells us how strong it is. It's negative 0.9993. Okay, that's really strong because it's very close to -1. So I'm going to go ahead and to help explain it, I'm going to say R equals negative 0.9993. Okay, so it's very strong, which means it's a really good fit for that data. Okay.